To begin learning about astronomy, we start with the basic movements or motions that the Earth makes in space. And that first motion is rotation. When the Earth rotates, we're basically saying that the Earth is spinning. And this spin is a pretty fast spin, so we spin once every 24 hours, which we typically call our day. That's our day. It's actually 23 hours and 56 minutes. What happens at 4 minutes? We need those 4 minutes to get ourselves pointed back at the sun. So a noon to noon solar day is 24 hours. But actually a rotation, a spin, is 23 hours and 56 minutes. And you're going to see an animation in just a minute. The second motion that the Earth makes is not a rotation, but a revolution. A revolution is the Earth going through an orbit. Now, an orbit is not a spin. An orbit really is what you're seeing on the diagram on the right. Orbiting an object, which just happens to be our sun. So we're orbiting once every 365 days. In reality, it's 365 and a quarter days, but we don't have a quarter day every year. Instead, we add those quarter days up, and every 4 years, those quarters add up to one extra day, which we put it at the end of February. We call that a leap year. So a revolution is our year. Our third motion is one that you don't really know a whole lot about because it's not a rotation, it's not a day or a year. It's something that happens a lot longer called a precession. And a precession is a wobble. It's almost like taking a top or a coin and spinning a top or spinning a coin. At first, it's spinning upright, but after a while, it loses some of its angular momentum and it starts to wobble. That wobble for the Earth is 26,000 years. 26,000 years is a long time, more than we can kind of comprehend, I think. So how do we know we're actually wobbling? What we do is we study the star that our axis is pointed towards. And let's take a look at that right now. On the left is a top. You can see the top of the top is wobbling. On the right, you can see the Earth, the same idea. And our pole goes right through there. And it actually wobbles over the course of time. So just like the top on the left, the Earth will go through that wobble. Again, how do we know this is really, really happening? Currently, our North Pole is pointed towards a star called Polaris. We call it our North Star, but we're actually about 1 degree off of Polaris. And about every 70 years, we shift another degree away from it. So if you add up all those degrees and all those years, we end up with about 360 degrees in a wobble over the course of 26,000 years. So what that means is that in about 13,000 years, our axis won't be pointed towards Polaris. Instead, it'll be pointed towards another star called Vega. So that's evidence of our wobble. To review, to summarize, our Earth goes through 3 motions: rotation, revolution, and precession. Let's see this in motion. This is a program we're going to be using in school, in our class. And let me point out the bottom left-hand corner. Bottom left-hand corner, you see 2 small diagrams. The one that's just to the right, not in the corner, is our rotational diagram. You can see us spinning. Notice we're spinning not straight up and down, but we're on an axis. And we're going to talk about that axis coming up in a few minutes and the next part of the notes. In the lower left-hand corner is our revolution. And it looks almost perfectly circular. It's actually very, very close to being a circle. The picture in the top upper right corner shows you the revolution on a side view, which makes it look very, very elongated. Not very accurate, but the one on the bottom left is the better of the diagrams. And that's 2.01 in your notes.